This is a supplementary summary to Lesson 12 focused on Activity 3. In Activity 3, you were to place coordinates based on a dilation from a dilation based on looking at a pattern of using different scale factors. And so you recognize that pattern, and then you place the coordinates as a result of that dilation. What I'm going to do is move you towards using an equation to place those coordinates rather than looking for a pattern from scale factors. But first of all, we're going to look at that pattern and then try to figure out how to use the equation. So in this figure, I'm going to add another scale triangle, slope triangle, with the coordinates at 1, 3. So the x value is 1, the y value is 3. So you're going to go over 1 and up 3. We're going to use a scale factor of 2 and a center of dilation at 0, 1. So this is a center of dilation, scale factor of 2. So what's going to happen is you're going to end up at 2, 5. So this length is going to get doubled to 2 along the x-axis and 5 along the y-axis. So how does that happen? First of all, the vertical distance and the horizontal distance. Good place to start. The vertical distance is the y-coordinate 3 minus 1. So this is 3 minus 1. So now you're going to shift this triangle down 1 unit. This is similar to what we just talked about. So that vertical distance is 2 units. It's 3, this 3 minus this 1. But notice that the horizontal distance is just the x-coordinate because that's 1 minus 0. Since this is already at the y-axis, you don't have to shift the x-coordinate at all. It is the same as the vertical distance. So the coordinates for after this shift, it's out 1 unit, up 2 units with a vertical distance of 2, and notice that the x value is the same as the horizontal distance. Now the coordinates will be multiples of the scale factor. And so if the new x value is going to be a multiple of the scale factor, if the scale factor is 2, then it's the x value, when it's scaled, is going to be 2 times whatever this x value is, this x coordinate is. Well, the horizontal distance is 1 unit, so 2 times 1 is going to get you out to x coordinate of 2. So the scale factor is 2. The x coordinate is 1, which is the same as the horizontal distance, and that's an important point. It's not shifted at all. It's the same as the horizontal distance. So the scale factor times this 1 is equal to 2. So the new x coordinate is going to be out here at 2. The y coordinate is going to be the scale factor times the vertical distance. That's what dilations mean. That's what scaling means, is you're multiplying the scale factor times a length. So it's the scale factor times the vertical distance, which is 2. So that new vertical distance is going to be 4. So the new y value is going to be related to that 4, but that's not going to be the y coordinate. That's the vertical distance. So now we're at 2, 4. So we've gone out 2 units and we've gone up 4 units. So that's actually dilating this triangle from a center of dilation at 0, 0 and using a scale factor of 2. So it's gotten us out to here. So this is a dilation of the red triangle. But how do we get back up to the line? Well, we have to add that 1 unit back. We have to shift that triangle up 1 unit because we previously shifted the triangle down 1 unit. Where did we do that? That was this 3 minus this 1. We shifted this triangle down this 1 unit to here. Then we dilated it out to here, and now we have to shift it back up. So what are the coordinates in the end? So the summary is the scale factor is equal to 2. Center of dilation is 0, 1. We started with a point on the line, which was 1, 3. This point right here. Dilated x, which is 2 times 1. So the horizontal distance was 1. The dilation factor, scale factor was 2. So 2 times 1 gives you a horizontal length of 2, and that's the same as the x-coordinate. The y-coordinate was this vertical distance, 3 minus 1, which is 2. You have to multiply that by the scale factor, which is 2. But then you have to add this 1. This is the key point right here. You have to add this 1 to get back up to the line. Right now, before we did that, we were shifted 1 unit down from the line. Well, it's all about getting the points on the line, so you have to get back up to that line. So you have to add this 1, and that gives you 5. So the x-coordinate is 2. The y-coordinate is 5. And so what I did is I traced the movement of this point right here. This is the vertex of the slope triangle that's on the line that's at the top part. And so I just traced that movement. So we started at 1, 3. We shifted it down 1 unit. We dilated it, the scale factor of 2. That went to this coordinate, 2, 4. And then we had to shift it back up 1 unit to 2, 5. And so here it is just animated a bit. So this is going to shift down, shifts down 1 unit, gets scaled up times 2. So it ends up this length. And then that length gets shifted up 1 unit to end up on the line at 2, 5. Okay, so now I'm going to go through the same thing again, but I'm going to use a different slope triangle, different line, and I'm going to keep track of the moves along this column here. And notice that for this slope triangle, it's shifted along both the y-axis and the x-axis. So it's shifted along the x-axis these 3 units, and it's shifted along the y-axis these 2 units. So you have to subtract those values. The idea is to get this triangle to 0, 0, do the dilation. It's going to dilate up and then shift it back by adding the 3 back and adding the 2 back. So those are the things to look for. So first of all, we're going to shift it to the left. So that's the x-coordinate 4 minus this 3 right here. It's going to shift it 3 units to the left, and it's going to put this angle on the y-axis. So shift it 3 units to the left, and that tells you the horizontal distance, which is 1 unit. So 4 minus 3 is 1 unit. And then shift it 2 units down. So we're going to shift this triangle 2 units down. So that's this y-coordinate minus this y-coordinate. So 4 minus 2. So we're going to shift this down 2 units. But we have already moved the triangle over here. So this is really the same 4 as this 4. And this is the same 2 as this 2. We're just shifting this triangle down. So now it rests along the x-axis, and it also tells you that the vertical distance is equal to 2. So this 4 minus this 2, take these 2 units away, you're left with this vertical distance, which is 2 units. So now we know the horizontal distance is 1 unit, the vertical distance is 2 units. So 4 minus 3 equals 1, that's the horizontal distance, and 4 minus 2 equals 2. That is the vertical distance. Let's go back up here and just review for just a moment. The center of dilation is 3, 2. The center of dilation is going to be right here. The scale factor is going to be 2.5. So we're going to scale this triangle up with a scale factor of 2.5. So each of these lengths are going to get increased by 2.5. So 2.5 this way, 2.5 this way, 2.5 this way. And so what are the coordinates where this point ends up? This point right here, 4, 4. Where does it end up here? So point A maps to where? So we've moved the triangle down over to the left, subtracting 3 units, and down by subtracting 2 units. So now the center of dilation is at 0, 0. Center of dilation is down here. Scale factor is 2.5. So now if we multiply each of these distances, the horizontal distance by 2.5, that's going to tell you the x-coordinate. So 2.5 times 1 gets you out to 2.5. And the vertical distance, 2 times 2.5, tells you the y-coordinate. You're scaling this triangle up by a scale factor of 2.5, starting at 0, 0. So it's 2.5 units out here, which is the same as 2.5 units along the y-axis. So the reason for shifting this over is now when you multiply, that tells you the x-coordinate, which is 2.5, and the y-coordinate, which is 5. So the scale factor 2.5, this is going to be dilated up with that scale factor of 2.5. And so notice that the x-coordinate now is 2.5. It's just the scale factor times 1. And the y-coordinate is 5, which is the scale factor, which is 2.5, times 2. And so now we have to move this triangle back. So the center of dilation, scale factor 2.5. So now move x plus 3. So now we're going to move it along the x-axis 3 units. So this point, 2.5, 0, is going to move along the x-axis 3 units. So what's 2.5 plus 3? That gets you out to 5.5. Notice that the 0, 0 goes to 3, 0. You're adding 3. And this point up here, you're adding 3 units. So this point is going to be out to 5.5, 5. So we've shifted this to the right 3 units. And I put this up here just so you can remember what this original triangle is, because it's going to get covered up in just a moment. So remember, this was that we had subtracted these 3 units and subtracted these 2 units along. This was the 3 units was along the x-axis, and the 2 units was along the y-axis. So now we have to add them back after we've done the dilation. So now we're going to shift this up by these 2 units. So this point right here is going to go up 2 units. This point right here is going to go up 2 units to 7. And that's what this looks like. So we've gone from 5, x value, x coordinate of 5.5, 0, to 5.5, 2. I actually didn't write it there, but this is 5.5, 2. And this has gotten shifted up to 5.5, 7. So the coordinates, A goes to from 4, 4 to 5.5, 7. So notice that the x-coordinate, we've added 1.5 units to the x-coordinate, and we've added 3 units to the y-coordinate. So look at what you're doing. You're taking the scale factor and you're multiplying it by the horizontal length or the horizontal distance, and then you're adding the 3 back. And you're taking the scale factor and you're multiplying it by the vertical distance and you're adding 2 back. So I'm going to zoom in on each of these and go over them just a little bit more. So this is the scale factor, 2.5. This is the horizontal distance. Remember, we got that from this 4 minus 3, x minus 3 from the first slope triangle. So this is 2.5 times the horizontal distance. Once you have that length, then you add 3 back to it to move it back over. So 2.5 times 4 minus 3 is 1. 2.5 times 1 is 2.5. Then you have to add the 3 back. So 2.5 plus 3 gets you to an x-coordinate of 5.5. So now you have placed that point at an x-coordinate of 5.5. What about the y-coordinate? Well, this is the vertical distance, y minus 2. Remember that slope triangle, we had 4 minus 2 to shift this down 2 units to the x-axis. So this is the scale factor, 2.5, times 4 minus 2 is 2. Well, 2.5 times 2 is 5. So that became a length when it got scaled out, when it got dilated. This became a length. It ended up at a y value of 5. And then you add 2 more to that, and that gets you to the y coordinate of 7. So you're at 5 along the y-axis, and then you have to shift this back up 2 units to get you to a y-coordinate of 7. So that's why this is up here as 5.5, 7 comes from this work, all the stuff that we went through. Take the scale factor, multiply it by the horizontal distance, add 3 back. Take the scale factor, multiply it by the vertical distance, add 2 back. And you can check this using the equation. So this is where you're starting to see the equation and the expressions for dilation start to work together. So we figured out where the coordinate should be. It should be at 5.5, 7, 5.5, 7. And then we can check that using this equation. So the equation is y minus 2. This is the vertical distance. So it's this y minus this 2 right here over x minus 3. This is the horizontal distance. So this x value minus this 3 gave you the horizontal distance, and that ratio was 2. That told you that the vertical distance was twice as long as the horizontal distance. So now replace y with 7, this 7 right here. 7 minus 2 is equal to 5. So now you're taking this 7 and you're subtracting that 2 units. That tells you that this vertical length now is 5 units long. This is the dilated triangle. And 5.5, this x value minus 3, gets you to 2.5. That tells you that this horizontal distance is 2.5. Well, the 5 is 2 times longer than 2.5. So this 5 is 2 times longer than 2.5. So that ratio equals 2, so that checks. This point is on the line. So you plug these coordinates into this equation and you get an answer of 2, which shows you that the vertical distance is twice as long as the horizontal distance. So things work. And I did this one more time for you, where I took everything away and I'm just following just this coordinate right here, 4, 4. So an x value of 4 and a y value of 4. So what's the first thing that we did? We subtracted 3 from the x coordinate. That shifted this triangle over to this y-axis. So that got us to 1, 4. So the x coordinate is 1, the y coordinate is 4. The next thing we did is we shifted this triangle down 2 units. That got us to 0, 0. And the lower side right here rests along the x-axis, and the x coordinate is along the y-axis. So the y coordinate, let me restate that, the y coordinate is along the x-axis and the x coordinate is along the y-axis. And so then we dilated this up with a scale factor of 2.5. Well, 2.5 times 1 gets you to this 2.5 right here. Remember that the scale factor times 1 is the scale factor. And 2.5 times 2, so this is going to be the scale factor times 2, is going to get you to this 5. So this scales up to 2.5, 5. And then we have to add those, what we took away, we have to add it back. So this x coordinate, so this is the dilated copy now. But now we're going to slide it back by adding 3 to 2.5. That gets you over to 5.5. Y coordinate is still 5. Just sliding this straight over. But now we have to finish by sliding this up to its actual coordinates on the line. So it's at 5.5 for an x coordinate, and we add 2 to that 5 to slide this up those 2 units that we took away originally to get us to 5.5 for the x coordinate and 7 for the y coordinate. Keep looking at it, keep thinking about it, and it will make sense to you what's going on. So now I'm going to suggest some practice problems, a little game you can play with a partner. I'm going to do this in a separate video.